to TalentSprint series on most frequently asked coding questions. In this series, we are taking a look at a variety of interesting questions that have been asked in interviews and written exams over the years. We are not only giving you the solution, but also providing you tips and pointers along the way to help improve your coding style and make you a professional coder. So let's jump into today's video. In today's video, we are going to write a program to find the sum of factors of a given number. Now this question you might have seen in various platforms before, or it might have been asked to you in the interviews that you have already given. So let's take a look at how to write this program. Before jumping into the program, let's be clear about what factors are. Factors are a set of integers that when multiplied together give us a particular number. For example, as you can see on the screen, 2 and 142 are the factors of 284. Since 2 and 142 multiplied give you 284. And there are some numbers that have more than a single set of factors. So for example, let's take the same number 284. There is another pair that can give you 284. That is 4 and 71. So 4 and 71 again, when multiplied together, will give you 284. So in this program, we are going to find the sum of all the factors possible of a particular number. So as you can see, 1, 2, 4, 71 and 284 are all factors of 284. So our program will give us the sum of all these factors. Now in this function, we have taken the number whose factors we have to find as an input parameter, and fsum variable here is created to hold the sum of all the factors. Now how are we calculating the factors? We have simply given a for loop which will divide our number by all the numbers from 1 till the number 1 by 1, and anytime our number is divisible, which meets our if condition, we'll add it to the sum. Otherwise, we'll move on to the next iteration. So this is a very simple and straightforward way of finding the sum of factors of a particular number. Now let me show you another interesting way to do the same program. So in this slide, our function name and input parameter remain the same, but we have reduced our number of iterations in the loop. How? Let's see. First off, we already know that 1 and the number itself are the two factors of a number. So there is no need to do these two iterations in the for loop. So to execute the for loop without these two iterations, we have already added 1 and the number itself to the fsum, which is in this particular step. So now fsum is not 0, fsum is 1 plus the number itself. So now moving on, we'll start our loop from n is equals to 2. Since 1 we have already added, we need to check from 2. And we will not check till the number, we'll only check till n by 2. The simple reason for that is after n by 2, the numbers that come are simple multipliers or squares of the numbers that have passed before. So we need not go through all those iterations, we need to check only till n by 2. Now inside the while loop again, we are doing the same process like we did in the for loop before. We are dividing our number by the numbers from 2 to n by 2, and if at any point of time our number comes out to be divisible, we add it to fsum. And finally, when the while loop completes, we are returning fsum. Let me show you another interesting way to approach this particular problem. So we just saw how we reduce the number of iterations of our for loop or while loop. Now in this particular slide that you see on the screen, again we have the same function and we are passing our number as input parameter. And inside we have used the same concept that we are adding 1 and the number itself to fsum before we get into the loops. Now inside the while loop, what we have done this time is we are checking if n into n is less than the number itself. So till our number multiplied the number square is less than the number, we'll continue the iterations, and as soon as it goes equal to the number or more than the number, we'll exit out. So for example, let's say if we have the number 81, let's take a look at what will happen in the first iteration. So we are starting with 2. Now 2 is not dividing 81, so we move on to the next iteration by doing n plus plus here. Now we move on to 3. Now 3 can divide 81. So what we are doing is, first off we are adding 3 to our F sum. Also now correspondingly num by 3, that is 81 divided by 3, that also will be a factor of 81. So in the same iteration of while loop, we are adding 2 factors to our F sum. So that is 3 and 27. Alright, and similarly for all the upcoming iterations, if we find one factor, we also add the corresponding other factor whose combination would lead to the number. Now finally, for this particular case, when we reach 9, so when the number is 9, 9 into 9 is not less than 81. Now it is equal to 81. So we will exit out of this first while loop. And now we will go into the second if condition that we have here, which is simply for the numbers that are perfect squares like 81. So 9 into 9, since it is double equals to 81, so 9 is also should be added as factor of 81. So to do that, we have added this small if condition at the end. Now what it will do is, it will add 9 to the F sum, and finally once all this is done, we are returning F sum. So as you saw in this video, there are always multiple ways to approach towards the solution of the problem that is given to you. Whatever clicks first might not always be the best, but you can think on it and find out ways to improvise your program to make it the best perfect solution for the particular problem. We are going to see many more interesting questions like this in our upcoming videos, so please don't forget to subscribe. And if you have any questions that you want us to take up in this series, please leave a comment below or drop us a mail at the email ID mentioned on the screen. Thank you so much for watching, and happy coding.